Sorry. Okay, so this one here, I probably could do this. No, I can't do this doing divergence. I'd have to show this limit is not equal to 0. I might be able to actually do that. I'm going to give that a try. So the lim as n goes to infinity of the ln of n over n. If I plug in infinity, I get infinity over infinity, so that is a L'Hopital's rule candidate. So I get the limit as n goes to infinity of 1 over n over 1, which is this. I put a little lopes here. The limit as n goes to infinity of 1 over n, which is equal to 0. So whenever this happens, the divergence test or the n-term test is inconclusive, so this does not help me. So I just wanted to go through that. Okay, so divergence test is out. Geometric doesn't feel very geometric at all. P-series, not an option here, because I can't really rewrite this, so there's just one n in the denominator. So I'm gonna have to go to the integral test, and I know it's integral test because I can do u substitution on this and it'll work out. So first thing you wanna do is 2 to the b, make sure you write down a limit statement. The ln of x over x dx. Notice that I replaced all the n's with x's. So u sub, I get du equals 1 over x dx, sorry. So this just becomes the limit as b goes to infinity of 2 to the b of u du. Right, because this x and cancel, then this u and ln go away. This becomes the limit as b goes to infinity of u squared over 2 from 2 to b. And then this becomes the limit as b goes to infinity of the ln of x squared over 2 minus the ln of 2 quantity squared over 2, right? So I kind of skipped a step here. I should have rewritten this as the limit as b goes to infinity of the ln of x over 2 quantity squared from 2 to b. So sorry about that. Okay, so now here I am. So now if I take the ln of, sorry, this should be b here, my mistake. If I take the ln of b as b goes to infinity, this thing is going to go off to infinity here. So that is very large. This is just going to be a constant. If I take infinity and I subtract off the ln of 2 squared over 2, that's not going to help me. So therefore, this is a divergent improper integral. And since the integral diverges, that means I can conclude that this series also converges. So this is just going to be diverges by the integral test. So what am I looking for here? Number one, you didn't need to do this little piece here. I just thought, hey, wait, this might actually work. It didn't work out because if you try to do the n-term test or the divergence test and you get 0, this is inconclusive. It has to be that the limit does not equal to 0. So this didn't help me at all. So they have to do the improper integral, so all the n's got turned into x's. It's usually a u sub, so I'm gonna look for the u sub notation down here. Make sure that you have the limits written each time. So notice I have the limits, in this case, 4 different times. I don't rewrite the limit at the very end because I evaluated the limit in between these two steps, if you will, in my head. So therefore, that's why the limit is gone. I'm looking for you to say diverges by the integral test. Obviously, if it goes to infinity, you say diverges. If this number was some finite number, you would say converges by the integral test. I think that's just about everything.